Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm vocalizing my thoughts while solving the 40th Project Euler problem. As always, I will link to Project Euler and my repository in the description. Let's dive in. Problem 40 is Champernowne's, I'm probably not pronouncing that the way it wants to be, constant. An irrational decimal fraction is created by concatenating the positive integers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so on and so forth. It can be seen that the 12th digit of the fractional part is 1. If d of n represents the nth digit of the fractional part, find the value of the following expression. And then it's d1 by d10 by d100 by d1000, then 10,000, 100,000, and a million, I believe. Okay, so once again, Python is going to make this really easy. Let's go ahead and copy this. Make our new file. Just making this a little bit. Okay, so the hardest part of this, I think, is going to end up being deciding how long do we want to do this? So here's going to be our general strategy. Our general strategy is we are actually going to make this irrational decimal fraction, or at least the part after the fractional part, we're going to make it as a concatenated string. Obviously our string needs to be at least 1 million characters long. So that's actually going to be our strategy, is we are going to make our string at least 1 million characters long, and then we're going to do this multiplication. Let's go ahead and get started here. And we'll copy over this limit as well, because we are going to need that, I think. But instead of 1,000, it actually needs to be 1 million. And then what we're going to do is we're going to have fractional is going to be a string, and then we're going to have n equal to 1, and we're going to say while length of fractional is less than the limit, fractional, do we have plus equals? I don't know if plus equals works. Is there like an append? Okay. Fractional equals fractional plus string of n n plus equals 1. And then we are going to print fractional 1. Okay, hold on. Okay, so we can't quite do that. We can fake it, though. If we start it as 0, then we can fake it out a little. So that times fractional of 10 100 1,000 10,000 100,000 1,000,000, double checking that I've got that correct. And this should just give us the correct answer. So let's find out. Oh, and it reformatted for us. That's fine. Okay, so it is taking a tiny, tiny bit longer than I thought it would, but that is okay. It shouldn't... I mean, it's going through this. So it's building out a relatively large string here, obviously. And honestly, I probably could have started this with a dot instead of with a 0, and I like that idea better, so I'm going to change to that. Oh, cannot multiply sequence by non-int of type string. Well, we're just gonna have to do this, aren't we? And then we close all of these parentheses. And now we should get the correct answer. Okay, starting at 1511. Don't go through for a teeny time, for a little bit. Building out this big string. There's probably a way to like one-line this, or we could make this some other sort of loop, perhaps. So it's possible that this could be done in a slightly cleaner way, maybe, but let's see if we've gotten our correct answer here. And double checking, it took us 33 seconds, roughly. So that's well within our 1 minute limit. And that is the correct answer. So just to do a quick review, we are able to do this because Python is really, really good at exactly this sort of problem. All we did is we created a string representation of the fractional part. We included the decimal part just so that we could just do 1, 10, 100 instead of having to do like 0, 9, 99. That just seems like it would be more confusing to read. But yeah, all we did is we just counted up all the integers until we got the fractional to be at least 1,000,000 digits long. And then we just did our multiplication using index referencing for our string and casting back to integers. So that's all there is to it. This one was a really pretty simple one. So let's call it there for today, and I'll catch you in the next.